Imagine you flag down a boda boda in Kampala. The rider tells you it's 1,000 shillings just to sit on the bike, and then 500 shillings for every kilometer you travel. If we map out this journey on a graph showing distance against cost, a clear pattern emerges. At 0 kilometers, you owe the 1,000 shilling base fare. At 1 kilometer, you owe 1,500. As these constantly accumulating costs are plotted, they connect to form a perfectly straight, upward trending line. Every straight line on a graph follows a specific rule that describes exactly how it behaves. We write this as the equation y equals mx plus c. To read this rule, you only need two pieces of information. The m represents the gradient, which tells us the steepness of the line. The c is the y-intercept. This tells you the exact starting height where the line crosses the vertical y-axis, which in our boda boda ride is that initial 1,000 shilling base fare. By identifying these two values, you can accurately calculate the cost of a trip across the city, or model any other scenario where a value grows at a steady, unchanging rate. Let's see how you actually graph a specific mathematical rule. We will use the equation y equals 3x minus 2. To start, we need to create a simple table of values. The easiest way to build it is to use the zero trick. If we plug in 0 for x, 3 times 0 is 0. Leaving us minus 2. This instantly gives us our y-intercept at the coordinate 0, negative 2. You must be careful substituting negative numbers. If we choose an x value of negative 1, we multiply 3 by negative 1 to get negative 3. Subtract 2 more, landing at negative 5. Our second point is negative 1, negative 5. Finally, we pick a simple positive number to finish our data set. Substituting an x value of 1 gives us 3 times 1 minus 2. Leaving us with a y value of positive 1. Now we follow the golden rule of plotting. We take our 3 calculated points, place onto the coordinate grid, and use a straight edge to connect them. Relying on only 2 points is a trap. 2 points will always connect to form a straight line, even if one calculation is wrong. That third point acts as a built-in safety net. If all 3 dots don't align perfectly, you instantly know you have an error. We can also work in reverse by extracting a mathematical rule from raw business data. Consider a local water tank filling service in Barara. First, we find our y-intercept, the c in our formula. This is always the fixed cost. Here, the service charges a flat booking fee of 5,000 shillings before any water is pumped, so c equals 5,000. Next, we find the gradient, or m. This is the recurring rate of change per unit. Since the water service charges 2,000 shillings for every single jerrycan they fill, our gradient is exactly 2,000. By combining these two real-world values, we generate our final usable equation for the total cost. Y equals 2,000x plus 5,000. Take a moment to test this out. Pause the video, write down this equation, and calculate the total cost for filling exactly 8 jerrycans. Let's check the substitution. We replace x with 8. 2,000 times 8 gives us 16,000. Add the fixed 5,000 booking fee, and the total cost comes to 21,000 shillings. Translating physical resources like jerrycans into mathematical variables allows you to project costs at a larger scale without having to count them manually. Let's imagine a competing water service opens up across town. They decide to charge a slightly lower booking fee of 3,000 shillings, but they keep the exact same rate of 2,000 shillings per jerrycan. Looking at this chart showing both pricing models side by side, we see a crucial geometric rule. Because both equations share the exact same gradient of 2,000, their lines run perfectly parallel to each other. They will never intersect. You also need to watch out for trick questions involving special cases. If an equation is completely missing the y variable, like x equals 3, it creates a strict vertical line. If it's missing the x variable, like y equals 4, the line is completely flat and horizontal. Here is your complete straight line toolkit. The formula y equals mx plus c holds everything you need. The m determines the gradient and parallel lines, the c tells you the starting height, and always plotting 3 points keeps your math in check. Mastering this formula allows you to turn the physical mechanics of growth and cost into a model that predicts exactly how one variable will impact another.